All right, everybody, welcome to the Water Lecture. This is Biology 1100. We're going to cover some topics tonight that aren't covered in your book, but they're very interesting and have bearing on everybody. They're important for everybody. So you've got your handout. I'm going to go ahead and just follow the handout right on down. First thing we're going to talk about is how streams naturally clean up. Streams clean themselves up naturally using bacteria. Mostly using aerobic bacteria. So let's say if this is a stream flowing this way, we have an effluent pipe putting some type of pollution into the stream here. If the stream is moving this way, it will take a matter of time as we go downstream, and the stream will naturally clean up the pollution that's involved, any organic matter. It works better, it's aerobic bacteria. It works better when it goes over cascading rocks, when it goes over shoals and it aerates. But in this way, streams will naturally clean themselves up if they get polluted. It might take a few miles. Maybe there's another pipe coming into it. These effluent pipes that can put pollution into it. Sewage treatment plants work off of the same principle. They recreate what happens in nature. We're going to talk about that in a few minutes. Dissolved oxygen, let's move on to that. Oxygen is important for all living things. Obviously, if you're a terrestrial organism, it's not so hard. But even underwater, oxygen is key to all living things, fish included, invertebrates, whatever's there. So they breathe through dissolved oxygen. So there's dissolved oxygen in the water. The higher the dissolved oxygen, generally the cleaner the water. Around here, this part of the country, southeast, Georgia here, Alabama, a dissolved oxygen reading of 10 parts per million, 10 milligrams per liter is quite high. That would be a mountain stream. Swamp in South Georgia, South Alabama in the winter, in the summertime, quite hot, might be as low as 4. Okay, let's go over how sewage treatment plants clean up. It's very similar to what they recreate, synthesize what happens in nature. So a sewage treatment plant will first have water coming in through a bar grate. You get out the shoes and dead animals and big things. From there, the water is sent to a clarifier. You've seen these big round structures you see off to the side. It's got a boom that swings across the top, goes around the top, it gets the foam. There'll be foam on top, that'll scoop the foam off the top. The solids will settle out in the bottom. Solids, organic matter, we're talking about treated sewage here. This is coming in from your sewage it's coming into your sewage treatment plant. You seldom see toilet paper in a sewage treatment plant. You might see a milk, it's disintegrated by the time it gets there. You might see, even if it's close by, like Oakland Park here is right next to the sewage treatment plant, you might see a little white milky color in there. You do see a lot of feminine hygiene products in there that don't decompose. This goes in, so that the water comes in, bar grate, filters out the big things, comes in, this is called a clarifier. Again, there's a boom that swings across the top, skims off the foam. The solids will kind of settle out. Down in here, there's bacteria working to clean it up. The rest of the water, which now has the foam off the top and been settled out a bit, leaves the clarifier, goes into another big round. This one has a boom across also. This is called the trickle filter. It's full of rocks, algae on it. This boom will swing around and pour the water out as it goes along. As it goes through these rocks, there's aerobic bacteria. It filters through the rocks. They're cleaning it up again also. Finally, it comes out of there. Goes into a chlorine contact chamber. Chlorine is added to give it a little disinfectant. and then it flows, and you can flow out back into the stream. Remember, this is treated sewage. It doesn't have to be treated to drinking water standards. It has to be treated well enough for it to go into the stream and river and have the river clean it up the rest of the way like I showed earlier. So there are biologists who go out and study the river, come up with all the parameters they need, and then they determine how much in-stream waste concentration, how much sewage it can take. Yes?
And the chlorine doesn't kill the bacteria that's in the stream naturally?
That's a good point. You have to have a certain amount of chlorine in. The chlorine contact chamber is always, takes a long time so that, you know, it'll go through it, it'll mix. You're not supposed to have it too heavy because you're right, chlorine kills. So once chlorine hits the stream, if they put too much chlorine in it, then it can cause a fish kill. And then someone like me, a biologist, will get called back out again to have to deal with the fish kill. Now right before it hits the stream, it comes out through a pipe again, effluent pipe. It's going to hit a lot of rock at first, big rocks there to get it aerated right away. It's called riprap. Then it goes back into the stream, a flowing stream. You don't want to put treated sewage into a pond or a lake. It's not moving water. It's not aerated. It's not going to clean up as much. Ideally, you want aeration going over shoals, tumbling over it, having water like shoals, tumbling water. That's going to help clear it up. So, again, this is wastewater treatment. It only has to be cleaned up enough to make it where it can go back into a stream or a river that's large enough for it to clean up the rest of the way. Next on our list, let's talk about septic tanks. I'm going to go ahead and erase this. Everybody have this? A septic tank works off the same principle that we have here. Anybody here have a septic tank? We got a couple. I know I got one. Okay, septic tank. A little lopsided. Water will come into your septic tank. Septic tank needs to be buried at least 3 feet under the surface. You've got a cap so you can drain it. Let me draw this a little better. There's a berm in the middle. You see these riding around town on the back of trucks. Sometimes you have to look closely to see whether it's a septic tank or a vault for a, what do they call them, for a casket. Very similar. So your water will come in here. Again, the water will first fall out. The solids will fall out. Down here you got bacteria. So, and then the water that doesn't fall out, the water goes over this berm. It falls out doubly. So all of the heavy stuff is going to settle out to the bottom. We've got bacteria to clean it up, leaving your water to go through your drain field. This is your septic tank drain field. I've driven it, it's a 2-dimension here, but it'll be horizontal, usually buried into a PVC pipe with holes in it, buried into about 3 feet of gravel. The water will go through there, then it will, as it comes out through there in the gravel bed, gravity will trickle it down through the ground, and it'll clean up naturally as it goes through the ground. Every once in a while you might need to have your septic tank pumped out. If you're not careful and you put a lot of chlorine in cleaning, you can kill all your bugs out. Now, I didn't mention that earlier on the sewage treatment plants. Frequently, like in Columbus here, there are big industries that have toxic stuff that can go into it. They're supposed to have their own treatment first before it hits the municipal, the city sewage treatment plant. A lot of times they don't do it. It doesn't happen. Accidents happen. Something bad will hit the sewage treatment plant and kill off all the bacteria in the sewage treatment plant. This happens. I don't know how regularly, but it happens. In that case, it's not the end of the world. This sewage treatment plant manager will go to another sewage treatment plant in a neighboring town. He'll only need to get a couple jars full of their sludge from their bottom that's got all the bacteria. Pour it back into his sewage treatment plant. That bacteria will magnify within a couple days, will multiply within a couple days. You'll have your bacteria back again. So that does happen from time to time, and that can happen in your septic tank also. I cleaned out my toilet my toilet, since I do have a well septic tank and I have chlorine in my water, a lot of algae will grow in the water and your nasty stuff in your toilet. So I poured in some Clorox in there just to kill it, let it sit for 12 hours overnight. But when I flushed it, I made sure I flushed the toilet a whole bunch of times because I didn't want that Clorox in there to hit my septic tank all at once and kill my bacteria, my beneficial bacteria. That's how septic tank works. Let's go ahead and just right over here to a well. Here's the ground. As water rains on the ground, is that a little too high? Basically what happens, gravity takes water through the ground. Around here we have about 6 or 8 inches of topsoil, hopefully. Then we hit some clay, and finally we hit bedrock, granite bedrock. Very tight spots, very, very tight. What actually happens is a water molecule, as it goes down through the ground, it might take weeks and weeks or months to get down to an aquifer. As it goes through the ground, the H2O molecule is pure water. Anything that's attached to it, any contaminants attached to that water molecule are sheared off as it goes through these very tight spaces. You're talking clay, bedrock, it might take forever to get through this, but as it does, it finally collects down into here in an aquifer, and it's in a clear, purified state. Then all you have to do is drill your well down into your aquifer, and you got water. When they come out, the well drillers, they can charge you by the feet. If they go down 200 feet, don't get water, you're in trouble. You still got to pay for it. They're going to pull up and move on the other somewhere else and try to on the other property and try to get some more. They're usually pretty good about knowing how much water is in the area. So I haven't seen it where they've had to drill several times, but it's not cheap. But they come onto your property. Like I say, they know the area. They'll drill a well down. My well is 250 feet. My pump went out. I know because my submersible pump went out a couple years back. They had to pull it all up, and they measured it when they put the new one down because I got charged by the foot for the new line going down. Okay, a water treatment plant. A water treatment plant's different. That takes water right out of the river, here the Chattahoochee River, right here at the Oliver Dam, takes surface water, and it has to purify it enough for us to drink it right out of the faucet here. That's a lot more than wastewater. Remember, wastewater has to be cleaned up just enough, and certainly not to drinking water standards, but just enough where it can get to the stream, and the stream can clear it up the rest of the way. Here it's different. Here you have to take this water and purify it all the way, and again, they recreate what happens in nature. The big water plants, that's less than a mile from here. If this was a daytime class, we could take a field trip there, but they have sand filters. They run it through filters that are jam-packed with sand. They just run it through lots and lots of different filters. Sometimes they hit it with ultraviolet light. They hit it with fluorine, chlorine. Keep that in mind. If you have a well, you don't have any fluorine in your water. So you have to, of course, you have fluorine in your toothpaste. Public municipal water supplies add fluorine into the public water to help with cavities and things. So again, for drinking water, of course, it has to meet pretty clean standards. They just recreate what happens in nature by purifying it, filtering out, continuously filtering it out, adding things to it to kill it so that the water can meet drinking water standards. Okay, next on the list is erosion and sedimentation. Erosion and sedimentation, referred to as ENS, is the largest pollutant to our waterways nationwide. What happens is people build around a stream, they violate the buffer zone. We need to keep vegetation around streams. People like to build right on the stream, have a nice house on the stream. Development comes on, they build down, then you have exposed soil. Rainwater hits it, it'll wash into the stream. Silt will cover all of the bottom of the stream, the rocks in the stream. What is the bottom of the food chain in an aquatic system? Plants, algae. So if all of the rocks are getting covered with silt and algae can't grow, it chokes out primary production. All the silt goes into all the little interstitial spaces in between the rocks, choking out all the aquatic insects that are in there, also helping clean up the stream. I didn't mention that earlier, but there's a lot. The best way to determine how clean a stream is to look at the aquatic insects that are present there in the larval form, the immature aquatic insects. Very time consuming, but that's, you can sample water, taking all the chemical parameters. It looks clear, it looks fine chemically, but you don't really know biologically. I've seen very clear water still not be that clean as far as aquatic organisms. So the best way is to go in and sample the aquatic insects, the aquatic organisms, the invertebrates that live in underwater during their larval stages. Okay, so erosion and sedimentation goes along with that watershed concept. Here's a stream coming in, another stream coming in, stream coming into a big stream. I'm going to draw dashes around the stream to mark it off as a watershed. We know that this is a stream here, that it's in a valley, right? You're not going to have two streams right next to each other. The stream is eroded through a little valley. This is the ridge of this valley. This is the ridge of this valley. It goes down lower. There's another stream here. Here's the ridge for this valley. So this here is a small watershed. So any rain that falls here will flow into this stream. Any water that flies on the other side of this ridge will flow into this stream, which is another watershed. Do you see that? Water flows over here on the other side of this ridge. It's not going to flow into there. It's going to flow into another stream here. So that's a small watershed. There's another small watershed. Here's another stream here. Here's another ridge. So that would be another watershed. Then, of course, this stream, this whole thing is a watershed. Any rain that falls out here is going to come into this stream, right? Anything out here. Let me draw Georgia. We have watersheds that drain into the Gulf of Mexico and that drain into the Atlantic. It's different watersheds. If it rains east of Atlanta, that water goes to the Atlantic. If it rains west of Atlanta, that water goes to the Gulf. That's a big watershed there. So I'm going to draw Georgia. State of Georgia. Here's Atlanta, Columbus, Macon, and Augusta, Savannah. So again, I used to live in Athens. Any rain there, it flows here. This is South Carolina. Here's the Atlantic. Anything that rains in this part of the state will drain over here and drain to the Atlantic. Where we are at over here, anything that rains, the Flint River is a cutoff here. There's a Flint River watershed. We're in the Chattahoochee River watershed. Anything that rains here is going to go into this river and end up down here in the Gulf of Mexico. So watershed concept's important as far as, I used to work in water quality, I think I told you all that, and in the 80s we did a lot of water quality work. We had billions of dollars worth of federal grants, we upgraded all the sewage treatment plants, we did everything in the early 90s. After 10 years of all that hard work, we came back in the early 90s and started sampling again, and things were still polluted. So what was that? If you look at the next thing, we have point versus non-point source discharges. Remember earlier I drew a pipe? An effluent pipe with stuff coming out. That's a point source you can measure. Maybe a ditch going into a stream. We cleaned up all those. We gave them all permits, and we still had the pollution. The pollution comes from non-point source. I think it's raining outside now. What's happening to all the tire residue, all the crap that's on the street right now? It's going into the river. What happens to all the dog poop that's in your yard and all the yards of the 200,000 people that live here in Columbus? All that's washing into the river. That's in this watershed. So when it came out, what we finally realized that cows put all the cows in the watershed. They're contributing. So it wasn't a point source where we could regulate it. It was a non-point source, just coming in through rain. So the only way to fix that was through education. So then we had to shift from regulatory, finding people, to educating people. And that's where we're still at now, is educating people about the watershed concept. You'll see a lot of towns, I'm not sure Columbus, they'll either stencil on their gutters, or they get these little things they can glue on it that say flows straight to the river, so don't throw your cigarette butts on the ground. Any cigarette butts that hits the ground here is going to make it to the river. You see people all the time throwing a piece of trash in the gutter, it's just gonna wash into the